Hi everyone, in this video we will see a little bit more in detail how the feedback works. The feedbacks, because we actually have two, why it is useful, and how it looks, how the pattern looks with feedback versus without feedback. So feedback is, I would say, always useful, especially useful if you want to pattern in grayscale. So now I will import a sine wave in grayscale, which is a grayscale patterning. And we can see here that I imported it from the geometries package. And these are the settings that I'm using. Any setting is really okay for grayscale as a test. Here I wanted to show you how patterning with feedback looks now. And this is something that you may have already seen. So we select our pattern, sine wave, and then I just refresh the patterning parameters, and we start with the feedback. Maybe we let any initial force from 4 to 6, and I like also to refresh the values here and remove some previous corrections. So let's start it from this pattern. It's something that you may have seen also in other videos, like in the quick setup of the NanoFrazor. I just want to refresh how a patterning with a feedback looks like. So now the NanoFrazor is trying to pattern using this initial right forces. And of course, we don't know which is a good writing force, so we start writing it and realize, okay, we're writing here too deep, and then feedback immediately kicks in to adjust the force so that the measured topography by the reader matches with the target topography that we import. So we can see that in just few lines, we are able to adjust the forces to optimal values. So this, so far, nothing special. Quite standard, but I would like to see together what we should look at when we use the feedback, and also maybe in the meantime I can stop because it's not very helpful to let the tool running just doing a sine wave at the moment. So let's see, first of all, some feedback parameters, right? So in this case, we have this depth feedback parameter. We have a global Kalman gain. In case we're using Kalman, we can change the gain if we're using a PID feedback. Usually I would recommend to use Kalman. It's very versatile both for grayscale and 2D. PID usually is better for 2D patterning. We can see here that we can pause that feedback whenever we are patterning, and we can also do the same here in case it's needed. By changing the gain, we can change the basically how fast the feedback can adapt. Sometimes it's helpful to reduce the gain if we see that the feedback is oscillating too much. So it's good to keep in mind that we can play with the gain, and we can also play with the gain for PID feedback as well. Regarding the feedback, we also seen that in the analysis we have this depth feedback here. Depth feedback gives us some iteration results. Especially we can see the convergence of the feedback and the total read lines and write lines that are done. In this case, we have more read lines because we have a upsampling factor of 4. So it makes sense that the read lines are 4 times the write lines. And here we see that as we progress, we have quite a good convergence of the data, while here they were more spread for the first initial lines. In the parameters evolution, we can also see when the feedback kind of converges, and we can see that at the beginning it's not really converged, of course, because we're writing too deep, and then the feedback is just up to a point where it finally converges. Then we have maybe some few points where the patterning is not perfect, even though we can see from our topography here that we're patterning quite well. Maybe for this line, for example, the feedback doesn't look converged, but it immediately adjusts the force parameters, force values, to make our measured topography match with the target. So these are some important indicators that you can see to check whether the feedback is working well. We can also see the decomposition efficiency of our feedback mode. And as mentioned earlier, we can decide to use both Kalman or PID. Now maybe we can try to pattern the same with PID. Usually I will do this pattern with the Kalman. We can see how it looks with the PID feedback. If you're interested in the formulation of these feedback modes, both Kalman and PID feedback are quite well-known feedback modes, so you can find easily on Google even the mathematical details of these two feedbacks. I will not dive into these details. We can see already that the PID is taking a little bit more time to adapt well with respect to the Kalman mode, but so far it's also working nicely. And even if the gain, as we have seen here, it's larger than the Kalman gain. Anyway, we see that probably the best result that we obtained was with the Kalman feedback. We can also see what happens if at some point I decide to stop the feedback. So we presume that the pattern is always going to look pretty much like this. So if I increase the temperature, for example, we'll pattern deeper. Okay, so we see the increase in temperature now, but this will not be adjusted by the feedback because it's paused. So if I remove the pause, now we should adjust again to this new change in temperature and adjust the patterning accordingly. When we use the feedback now, I can already stop this pattern because I would like to show you some settings. When you use the feedback, Kalman or PID, we can choose which forces we start writing. So in case we have a convergence of the feedback, we can start from the last converged state. In this case, we were using PID. So in PID, we have the last PID field or manual setting, or we can also do a force calibration model. Force calibration model can be done in the optional tool of the TSPL configuration. For the PID, we can choose which history line we want to use. For Kalman, we can use the last converged state. In this case, we just use the PID, so we don't have a Kalman last converged state. But this will automatically start the patterning with good values that were able to give us good results for our pattern. And if you start, let's say, maybe a new field, we can manually select the initial writing forces from minimum to maximum, because here we're dealing with a grayscale. So we will use 6 volt here and 4 volt here. And this is just a guess, then the feedback will start working. And yeah, this is pretty much how you can start patterning with the feedback. While we pattern without feedback, we can decide also to load right force limits from the PID field or the last converted state of the Kalman, or use the force calibration model. Of course, when you write without the feedback, then we will not have any adjustment unless we manually change, for example, the temperature or the force. So these are already like a brief introduction to feedback, but you should be you should be able to hopefully solve many or most of the problems that may have in understanding how this works and how to effectively use the feedback. Again, we've seen the gain, how it can affect the feedback. We've seen how to start the patterning with and without feedback, and also we've seen how to check at the depth feedback, its iteration results, and the parameters evolution in the analysis panel. So I hope this will help you be more successful with the NanoFrazor. And thank you for watching the video.